The best way to understand what happens with transformations is to look at transformations on a quadratic function or a parabola. So the number in front of everything, the a value, let's see what that does. Remember that this a value is going to change the y value. So whatever happens, we call it a vertical change. So it looks like it's making our function thinner when the values increase, and it looks like it's making our function wider when the values decrease. So when it increases, the way we would describe it, our a value would produce a vertical stretch, because if this were a rubber band and we were pulling it upwards, the more we pulled it up, the thinner the rubber band would get around the center. So it would get thinner and thinner. So a vertical stretch would make it thinner. A horizontal compression, if we are pushing it down, then it would get wider and wider. Kind of like what happens if you take a marshmallow and push it down from the top, it gets wider on the sides. So when this a value gets smaller, then we end up with a wider parabola. In other words, our a value is going to cause a vertical stretch or a vertical compression, depending on what the number is. Now let's look at what the next value is inside of the parentheses, exactly what that does when we multiply it by the x. So notice that it's changing the x values. So we call this a horizontal change. So this value looks like as it gets larger is also making our graph thinner. So if it's a horizontal change, the only way it can get thinner is if we're pushing from the left and from the right. So we're pushing from the left and the right, and it's going to get thinner and thinner. And it's called a horizontal compression. So as this value gets larger, as the value that we're multiplying by, as that gets larger, we're ending up with a horizontal compression. When this value gets smaller, we're pulling from left and right. In other words, we're stretching from left to right. So it's a horizontal stretch. So whenever this value gets larger, it is a vertical compression. But when that number gets smaller, it's a horizontal stretch. Now let's look at what the h value does. So as h increases or decreases, our graph moves left to right. So our h value actually moves our graph left to right. Our k value moves our graph up or down. So that gives us an idea of what each of those values do. For our exponential function, let's look at what our a value does. So as a gets larger, it's just like in the parabola, we're pulling the graph up and up. So it's a vertical stretch as a gets larger. When a gets smaller, we're pushing the graph down, and so that's a vertical compression. Now let's see what happens with this value that we're multiplying with the x. So as that value gets larger, notice that it's actually pushing the graph further in. So as that value gets larger, it's a horizontal compression. But as that value gets smaller, it's pulling the graph to the right. And so now we have a horizontal stretch. So our d value in this case is going to produce a horizontal compression when it gets larger and a horizontal stretch, we're pulling left or right, or pulling right when it gets smaller. So let's think about what our h does. So this value that we're currently subtracting from x, as that value changes, notice that the graph is moving left or right. So this controls our horizontal movement. So it's a horizontal translation, either left or right. Our k value, what it does, it looks like it's moving the entire graph, even the asymptote, it's moving the entire graph up or down. So let's summarize what all of this means. Our a value is going to move our graph vertically. So this value is a vertical change. And we say vertical because it's not directly affecting the x. It's what we're doing after we've applied our parent function. So after we've put it into the exponent part and worked everything out, then we're going to multiply. So in this case, we're changing the y values. So we call it a vertical change. In terms of how it changes vertically, what we noticed was that A is going to produce either a vertical stretch or is going to produce a vertical compression. And it depends on what value A has. So now let's look at what this interior value does. So this value, I put B here, but let's call it D to be consistent. So this D value, what it does is it's applied directly to the X. And so we call this a horizontal change. And as we know, horizontal is left to right. So this is a change that's applied left or right. And from what we looked at before, this change is going to either produce a horizontal stretch, or it's going to produce a horizontal compression, depending on what the number is. H was also applied directly to the X. So H is going to be another horizontal change. So this horizontal change from what we observed moves our graph either left or right. So this is going to be a horizontal translation and of course we know that the only way we can move horizontally is either left or right. And finally, let's look at what our k value does. So this is added at the end. So if you notice that it has to be something that is not directly affecting the x, it's something we do after we apply our exponential function, after we use our power basically. So it has to be a vertical change. Our k value, what we noticed before, we said it's a vertical change, but it moved the graph either up or down. So it's a vertical translation, either up or down.